Solving equations. These types of equations are going to have a variable in the exponent. To use this, we're going to have something like this. Y equals a to the x power, and we're going to want to solve for x. That's going to be our goal with these. So we are going to also move into here. We need to keep in mind that when we say log of a number, all of this entire piece here is a number. All of it together. Let me show you what I mean by that. If I do the common log of 375, I can use an approximation in my calculator. And let's say I wanted to pay someone log base 10, or the common log, of $375, whatever that means. Well, once I use my calculator, I would find out that that means that that's going to be $2, about $2.57. So all of this, all of it combined, the log and the number, all make up another number. So we got to keep that in mind as we go through solving these equations. So let's solve for x. We'll start here. 2 to the x power equals 16. One way to do this, we're very lucky in this case, side 2 to the x is equal, 16 becomes 2 to the 4th power, which means x equals 4. We lucked out this time. 16 actually became a base of 2, so we could apply this rule. However, there's another way that we could have done this, using a new rule. This rule says that if we have log base a of x to the b power, that means that I'm going to have b times log base a of x. This rule, we get to bring the exponent down in front, and it becomes multiply. Let's apply this to our previous example of 2 to the x equals 16. Let's say we didn't know that we could change 16 into a base of 2. Well, I can take the log, I'll use the common log in this case, and using the previous rule, log of 2x to the x is equal to log of 16. I can just apply the logarithm to both sides. My one rule says I can bring the x down. Log base 2 is equal to log base 16. And now I'm going to view this log of 2 on the left-hand side here. All of that is just a number. You can look it up in your calculator. You'll get some decimal number. But just like if it was 5x, I would divide the 5 out. Here, it's log of 2 that I'm dividing out. And very nicely reduce. On the left-hand side, I'm left with x. On the right-hand side, we need to be extra careful. But when you use your calculator, you're going to do the common log of 16. You have to hit equals, then divided by log of 2. And it should give you exactly 4. You can try it out with your calculator. Let's try another one. So we are going to have 3 raised to the x minus 2 power is equal to 7. Notice the exponent, the unknown, is in the is the x in this case, and that's what we're looking for. So I'm going to go ahead and apply the log. This time I'm going to apply the natural log. That's ln of 3 to the x minus 2 power equals ln of 7. You can redo this problem using the common log, and you'll see that you'll get the exact same answer that I'm going to get. Just recall, log base e of x, we rewrite that as ln of x, where e is that weird number 2.7 7, and it keeps on going. There's a reason in calculus why we choose to use this number, but your calculator only uses log base e, the natural log, or the common log, log base 10, like we used in the previous example. So we can use either. I chose the natural log. I'm going to take the x minus 2 and the exponent here. I'm going to bring that down. Now very nicely, I'm going to recall that natural log of 3 itself, all of that is just a number. So I'm going to divide both sides for the natural log of 3. I end up with the left side is x minus 2 equals natural log of 7 over the natural log of 3. Now, you need to believe that natural log of 7 is a number. Okay, it's about 1.9. And the natural log of 3 is about 1.1. So all of that divided together is going to give you a number. I'm going to go ahead and add the 2 to both sides. I'm going to get that x is equal to 2 plus natural log of 7 divided by natural log of 3. This is the exact answer. Your teacher may ask you for the exact answer. This is what they would be looking for. Your teacher may also want you to come up with an approximated answer. In this case, when we divide the natural log of 7 over natural log of 3 and then add 2 to that, I'm going to get 3.7712, which is rounded off, of course. The way you would do this in your calculator is you would take the natural log of 7 and hit equals, divided by natural log of 3, then hit equals, then add 2 to that. If you don't hit the equals, you run a chance of getting the wrong answer. So this is the approximated answer. Alright, let's try one more example. This one is quite complicated, actually. So just relax. We'll get through it together. Here we have 5 raised to the 2x plus 3 equals 31 raised to the 4x. Keeping in mind, when we take the log of a number, that result is also just a number. So we're going to treat log of something as just a number. I'm going to apply the natural log again. Again, you can redo this problem using the common log. You should get the exact same answer that I'm going to get at the very end. So I applied the natural log to both sides. Remember, that's that base e. And I use that because that's in your calculator. That or common log. My exponent rule says I get to bring down the exponent, 2x plus 3. I'm left with natural log of 5. On the right-hand side, the 4x comes down using the same rule, natural log of 31. Now this one's going to get quite messy, and in this case, I'm going to have to take the natural log of 5, and I'm going to have to use the distributive property to both. So I'm going to get 2x natural log of 5 plus 3 natural log of 5 equals 4x natural log of 31. Now, just like I would with a regular equation, keeping in mind natural log of 31 is just some number. Natural log of 5 is also just some number. What I'm going to do is I have some x's on this side and on this side, and so I need to move them to the same side. I'm going to subtract the 2x natural log of 5 to both sides. Keeping in mind the coefficient of x in this case is the negative 2 natural log of 5. That's what's being multiplied. I'll do that same thing to the right-hand side. 2x natural log of 5. On the left-hand side, I'm left with 3 natural log of 5 equals 4x natural log of 31 minus 2x natural log of 5. Again, on this side, the coefficient of x is 4 times natural log of 31. All of that is the number that's multiplied times x. And over here, it's a negative 2 natural log of 5 that's being multiplied to x. What I'm going to do is I'm going to take those x's, and I'm going to factor them out. And I'm going to be left with 4 natural log of 31 minus 2 natural log of 5 on the right-hand side. All I did was factor the x out using the distributive property. On the left-hand side, we have 3 times natural log of 5. Now I know this is hard to visualize, but on the right-hand side, the coefficient of x is all of this. All of it is the coefficient of x. And therefore, that is what I'm going to divide by. Just rewrote that for us. And now we're going to divide by all of this. 4 natural log of 31, that's just some number, minus another number, 2 natural log of 5. Doing that to both sides. 4 natural log of 31 minus 2 natural log of 5. Finally, x is equal to, here we go, 3 natural log of 5 over 4 natural log of 31 minus 2 natural log of 5. Whew, that's a big one. Getting all that in your calculator can get complicated. I'm going to leave it to you. Try to play around with that. And what you're going to get for this final answer is going to be about 0.4591 when it's rounded off properly. And there you have it. You may want to go back through this one and see kind of how everything works with it.